Hey guys, this is Surya from Skill-Lync. Hope you're doing well. Over the last 2 weeks, we have been discussing about research assistantship model that Indian students who are pursuing their computer science education can basically pursue in association with a professor at some of the top universities. In the screen, you basically see Dr. Vijay Chidambaram. He is an assistant professor at University of Texas at Austin. Before getting into this video, I want to kind of give you an overview of what this whole research assistantship is. When I went to grad school in 2011, one of the things that changed my view of education was the research assistantship that I did with my professor, Bob Rodens. The research assistantship that I did paved way for a fully funded admit and also paved way to my first job and all the other good things that happened to me. Unfortunately, if you're in India, you do not have access to work with some of the best professors and work on some of the best research that's happening in the industry. So we wanted to break that, and this particular program, how you can work on some of the best research that's going on in the industry. This program is going to be a 12-week research assistantship program where you as a group of 5 students work with Professor Vijay Chidambaram in order to embark upon a research journey. I have Dr. Vijay in this meeting, and I'll let him explain about this program and also explain what you will be working on as a part of this 12-week program. Vijay, thanks for joining us, and if you can give an overview about yourself and also give an overview about what you have envisioned for this 12-week research assistantship, that would be really helpful.
Hi folks, my name is Vijay Chidambaram. I'm an assistant professor at the University of Texas at Austin. I did my undergrad at CEG, College of Engineering Guindy in Chennai. So I'm quite familiar with sort of like how things are in India. And so one of the reasons that I'm doing this program is that there's a saying that I really like, which is that talent is equally distributed, but opportunity is not. So lots of very talented Indian students don't really get the opportunity to do PhDs and research and so on, just because like in the college that they are in, they don't have any research capabilities, right? And these can be like very smart, very motivated students, but still sort of like, if you don't have that opportunity, you can't really show your talent, right? So this is basically a program to help students in India who are who don't really have access to research capabilities to sort of like try and experience research. So what will happen is that over a course of 12 weeks, which is usually a semester here in the US, students will be working with me on a research problem. So there'll be like 5 students. So it's not like a student will be like alone and trying to do something really hard. There'll be 5 students. And what we'll do is initially I'll sort of like talk about one of my research projects, and I'll sort of give you background and tell you like what to read to sort of like get up to speed. And then once the group has sort of like understood what is going on, then we will try and extend one of the research projects that I have going on here. What helps here is that most of the research projects I work on are open source. So all of the code, everything is on GitHub. So what we will be doing is like, we would be selecting sort of like, 5 slightly different subtasks for the project, but the sort of background will be the same, and the students will be working together to do this. And this will be like over a course of like 12 weeks, because research is not something I can do immediately. So it will take like 2 or 3 weeks just to get up to speed, to understand what is going on and so on. So you really need that 12 weeks to get up to speed and then do some useful research. So I'm kind of hoping that, this is like a first step. I'm hoping the students, while they do this program, they enjoy research. They sort of like, it's sort of like they do this and they figure out that, oh, like I would like to do research as a career. And I'm hoping that it will help them, put them on the path to grad school to do a PhD or a master's. And if students work with me, like I'm quite happy to write letters telling sort of like my peers in other universities about like how awesome these talented students are.
Great. Thank you so much for that introduction, Vijay. Vijay, also can you explain a little bit in depth about the topics that these students are going to work upon? So while we were discussing earlier, you spoke about split FS and also recipe being the fundamental topics on which people will work on. And you also mentioned how it's associated to machine learning and what's changing in the whole ecosystem and how this research is important in the given ecosystem. Can you kind of give an overview about that?
Sure. The group I lead at UT is called the UT Systems and Storage Lab, and our sort of like high-level goal is to build the next generation of storage systems. So if you think about things like solid-state drives, hard drives, and so on, there's new technology coming out. So Intel has this new technology called persistent memory, which is like it's about 1,000 times faster than flash SSDs. So how do you build software so that you can get the full performance from persistent memory is still an open research question. So my group builds software to sort of like tackle this question. So the way my group works is there's a research question that we want to answer, and the way we answer it is we always build systems. So it's not like we do theory, it's like practical hands-on systems building. And so we have built like a recipe, which are concurrent data structures for persistent memory. And we built something called SplitFS, which is a file system for persistent memory. So we have other efforts going on in the group about like how do you build key value stores for persistent memory and so on. And another line of research in my group is how do you build storage for machine learning. And we have some papers coming out about how do you reduce memory consumption, how do you remove bottlenecks, and so on. So these are all like very cutting edge topics that like we don't really know the answers to. So my hope is that working on these topics will be exciting for the students, because like these are things where if we are successful in what we do, it will be picked up and deployed in industry, so they can have very good impact based on the research that they do.
That's really exciting. We see the other aspect that I wanted to ask you was about who can apply for these roles, right? There's only 5 roles, 5 openings that we can basically pick up. What would be the 5 ideal students? Say, for example, if I'm in my 3rd and 4th year, or if I've graduated and if I want to do my master's, can I apply? And what is the minimum requirement that I need to have? And what is the one particular characteristic that you would like to see in the candidate?
So I think in terms of technical background, we are looking for computer science students, and we are looking for students who have at least done like an operating systems course. So they would need that background to understand the research. In terms of like skills, I think what we are looking for is someone who has done well in their operating systems and their algorithms and data structures courses. So that's sort of like the background that we need. I mean, like for example, if you didn't do as well in networking, that's totally fine. We're not getting into a lot of networking in this project. In terms of like I guess like character traits that we are looking for, I think the main thing is you should have a lot of like persistence and determination. So research is not like a straight line path. It's not going to be like an internship at a software company where you go in and then in week 1 somebody tells you this is what you have to build and you build it for 12 weeks, right? So research is by nature a sort of like a messy process. So we will try something and it may turn out that it will not work, so we will switch and we will try something else. But you should not get discouraged by this, because like in research you're trying to find out the best way to do something. So that means that we will try a number of other ways which will not work, and this is so you have to sort of like have some determination to get past those hurdles. So that's the main thing we look.
The other aspect that I also wanted to understand was how this program works. Say 12 weeks, each week you will have a session as a group, and probably in the first half everyone will have the same goals, and in the second half probably the goals for each member in the team kind of diverges and probably converges at the end of the 12 weeks. Like, can you speak about that, and also can you give an estimate on the weekly number of hours that these students should put in order to kind of get a very good output at the end of 12 weeks?
I think what we're trying to do in here in this program is we want to mimic the experience of a student doing research with me at UT Austin. So undergraduate students at UT Austin do research with me similarly over 12 weeks. And what usually happens is that we meet every week. And we meet every week for between 30 minutes to 1 hour. And initially the meetings will be about, I will assign reading. So I'll say, hey, read these 3 papers or read this book chapter, and then we'll come and discuss. And so then they will have questions and I'll answer and so on. So the first, I think 2 or 3 weeks at least will be about getting them up to speed, and that will be common for everybody. Like everybody will be trying to understand the project, and the fact that it is common means that they can help each other out. So we want the group to understand as quickly as possible. After that, what we will do is I'll explain once they understand the research project. Then sometimes like sort of naturally what will happen is that people will gravitate to different aspects of the research project. Somebody will be like, hey, I really like this aspect, can I make it better? Another person will be like, I like this other aspect, can we make it better? But whatever the case, we will define 5 sort of like subtasks, one for each student. Let's sort of like begin working on that from weeks 4 to 5. So this program is different from the sort of like normal lecture series that you have in like Indian university, in the sense that a lot of the work is done outside of class, right? So it's not like if you just attend all of the like 12 lectures, you'll do well. You will have to put in some work. Like I would estimate between 5 to 10 hours a week outside of like the time that we meet, because like we're going to meet only for 1 hour, which is not very long, right? So it helps if like you've already put in the work and you're like, hey, I was trying to do this, I was stuck on this, and so can you help me? So we want to use the maximum benefit that we can get from either 1 hour that we meet. And so you will have to put in a lot of work outside, and it will require a lot of systems building, right? So you have to be comfortable writing code, and you have to be comfortable sort of like, like if something doesn't work, to go and try something else, because again, like this is not going to be like a normal course. So you're not going to have like a lot of like hand holding, right? I'm not going to be there to tell you like, oh, you got stuck in this, like, like try this other thing. So a lot of it will have to be like self-started. You'll have to figure out things on your own, but that is the actual research experience. So if you came to the US, this is what you would experience. It will be very close to that.
Very true. One of the aspects the research in the US allows you to do is to kind of understand your own capabilities in exploring new topics, and also understanding new topics and kind of making progress in that particular area of interest. So I would assume not only 5 to 10 hours, probably we can suck it out.
Yeah. I mean, I wanted to give like a minimal number of hours. So without putting in 5 to 10 hours, you're definitely not going to succeed. But beyond that, yes, like, I mean, like the more effort you put in, the better off you will be.
For example, the more effort, if you guys are interested in this program, and if you're watching this video, say 20 to 40 hours per week for 12 weeks is a lot of time. That's so if you're spending 40 hours, that's around anywhere between 500 hours in a 12-week period, and that will allow you to showcase, make further progress in the research that you're working on, and also that will allow you to get a very good letter of recommendation. And not only that, it kind of is the first step towards a career of your own choice in a university of your own choice. I'll let VC kind of explain the benefits of this program if done well. So what do you think are the direct benefits? What do you think are the indirect benefits, VC?
So the direct benefits are going to be, you will get admits in better universities while applying for masters and PhD. So there was this like recent tweet on Twitter where somebody applied for PhD and then they got rejects from everywhere. They then did a similar research internship for like a year and then they got an admit to Georgia Tech. So typically, like research experience helps a lot, because now you understand the process much better, and so you will have an easier time when you apply for masters and PhD schools. So that's the direct benefit, I would say. The indirect benefit is like now assuming you're sort of like you're unclear about like what you want to do sort of like in life, right? This will tell you very nicely whether you want to do a research career or not. So after doing this, you will know for sure whether, hey, I really love research and I want to do a PhD and then go work in a research lab or become a professor. You will find that out, or you will find out that like research is not for me. Like I should pursue some other path. But so that is also sort of like, I mean, as you said before, I think like you learn something about yourself, right? So you learn that either like this is something for you or it's not, and I think that also helps. And students also develop sort of like the ability to sort of like get through blocks on their own, because like nobody's going to help you in this, right? So it's like you will be stumbling through all these blocks and figuring out what to do, and so you will become more self-sufficient. So at the end of it, you will have more confidence that if somebody gave me like a vague research problem, I will know at least how to handle it, right? And in industry, like this is a valuable skill, because there's a lot of people who are very comfortable with like very well-defined goals. So if they tell you like this is the exact thing you need to build, lots of people are there to build it. But if the goal is sort of like undefined, like like we want to improve this product, but we don't know how to improve it. There are many different ways in which you can try. So then doing research helps you build up that framework. Okay, like this is what I'm going to try. If this fails, this is what I'm going to do next. This is what I'm going to learn from that. So that actually helps a lot. So that would be the indirect benefit.
great. One more benefit is if you guys are applying for a master's, research assistantships, which is basically your ticket for a funded admit. If you have a good research background and a good recommendation letter from someone like Vijay, what you would get is an opportunity to at least get into a research group, prove yourself, then progress to a funded admit or a research assistantship. Even if you don't get a funded admit from day one, you will get a funded admit from, say, probably the second semester. It saves you a lot of money. So, for example, VC did his master's at UW and then progressed to PhD. I believe he did not spend a penny for his master's and PhD. And I did master's at UW, and my master's costed me lesser than what costed me for my undergrad. So that's how much you can basically save from a research assistantship. So yeah, this is really, really exciting stuff. We are starting with a VC, and he is an expert in his domain that he's working in. So we are really excited to kind of kickstart this program. This program starts in the second week of Jan and goes till the second week of April in 2021. There are only 5 seats. There is a pure application process. If you want to apply for this program, you basically fill in the application process. The link is provided below. Please take a look at it. And you will have an interview as well in order to get selected. The interview will be taken by VC itself. If he gives a nod, you basically go to the next round. This is a paid program, so you need to pay. Yeah, thank you so much for taking a look at this video. VC, any final thoughts?
No, I mean, I guess like good luck to all the applicants.
Thank you so much, VC. So if you guys are interested, do check out the description link. Yeah, we are looking forward to kickstart this program. Thank you. Thanks, VC.